Ito. Okay na, wala na siyang feedback. Nagpi-feedback kasi kanina eh.
Okay na po, sir.
Okay. So, good morning. So, our first discussion will be start in PNP and other devices in Boylestad. So, gamit ko reference is Boylestad. And this is part of the book of chapter 21. Okay? Chapter 21 yung didiscuss ko, tsaka chapter 18 yata. Ay, dito pala chapter 17. Although doon sa sinend kong PDF, chapter 21 siya nakalagay. Okay? So, magkaiba lang kasing edition niya. I think yung na-upload kong edition is around lumuto ko ng edition yung naka-upload. 11 edition yata to. 7th edition. Okay? So this is the 10th edition. I think this is mas konti lang naman yung binago dito sa chapter 17. Tsaka konti lang naman gagamitin natin mga chapters dito. Yung chapter 17 and yung in this book chapter 17. In this tsaka chapter 17 pala. Pero dapat is chapter 17 to. Okay. So let's start in PNP semiconductor. Okay. So in this chapter nga, there are number of are important devices na hindi natin i-discuss na detail. Okay? In this chapter, so yung mga natin, mga two-layer semiconductor like diode, which is led into 3, 4, and even 5-layer semiconductor. In this particular chapter, we will focus on 4-layer PNP devices. Okay? And this will be consider introducing yung silicon control rectifier, we call that SCR, silicon control switch, which is the SCS, GTO, this is other type of thyristor din, gate turn off switch, gate turn off switch, yan, LASCR, which is like activated SCR, Schottky diode, diac, and triac. So yung yung discuss ko ng syllabus medyo kinopak natin dito so that we can have a easier way to understand this PNP device. So tandaan natin this type of meron ibig sabihin four-legged sila. They have sila tawag dito, four connector pero 4 layers sila, kaya nga pnpn. Okay, hindi katulad ng mga BJTs natin tsaka PET, they are PNP. Okay, kaya NPN. Okay, ibig sabihin 3 layer yan. Ganon din yung MOSFET natin. Okay, depende lang sa number of dopant nila o concentration ng dopant. Okay, ganon din naman dito, meron pa rin naman concentration sila ng dopant. But we can literally say na in this particular okay, pwede ba akong drawing yan? Pwede ko lang mag-drawing dito. Okay. I-insert ko lang yung pad ko. Ay. Wala yata yung parang ballpen niya. Ano nilagay? Wait lang class na. Hanapin ko lang yung pen dito. Which is meron tayong P tsaka N. Okay? Okay, which is meron tayong P-type tsaka N-type. Okay, which is sometimes ang mga example nito is yung diode natin. Okay? O yung mga power diode. Okay? Tapos yung yung mga sumunod, yung 3-layer, which is yun nga yung mga example ng mga BJTs and PET. Okay? So, PNP o kaya NPN. Okay? So, these are the 3 types. So, example niyan, mga BJTs and FET natin. Okay? Or MOSFET. Okay? Or the CMOS. Okay? So, they are 3-layer. So, in this particular, we will discuss more on 4-layer semiconductor. Which is P, NPN. Kaya NPN, NP, NP. So there are different kind of combination in this type of devices. Okay, so all of these are four layer semiconductor. Okay, so tandaan niyo yan. Okay, so yan yung mga following, which is increasingly important devices. Okay, example nito is yung UJT. We will also include in this PDF. Nandiyan na sa PDF mo dyan. Nakalagay dyan sa PDF. So those four layer devices which can control mechanism. Example, this is referred to as a thyristor. So in later discussion, we will most hear this thyristor. Okay, actually all of these are type of thyristor family. Okay, although the term is most frequently applied to silicon control rectifier kasi madalas ginagamit talaga yung silicon control rectifier, especially in controlling lights, okay, or any type of controls in a high power application to triggering small voltage. Okay, ganito yung ginagamit tong silicon control rectifier natin. So this chapter we will introduce some of yung phototransistor, opto-insulator, and then yung PUT natin, which is programmable unijunction transistor. Okay, so let's go down to the first one will be the silicon control rectifier. So within the family of devices, the silicon control rectifier is unquestionably the greatest interest, especially today. Okay, in early 1956, okay, tawag dito. In early 1956, Bell there's an industry which is that Bell Telecom Laboratories, which is has more common area in application in silicon control rectifier. Madalas kasi yun nga yung silicon control rectifier more on switching, high power transmission, high power voltage yung kino-control natin diyan. So madalas ginagamit yan sa telecom company. So this include relay controls, time delay circuit, regulated power supply, static switches. So yun yung mga application ng silicon control, no? Mga relay control, time delay. Okay, kasi makikita natin yung kung paano nagkakaroon ng time delay sa silicon control rectifier. Ano pa ba? Regulated power supply, static switches, ganyan. Motor control, chopper, inverters, batteries, battery charger, and then protective circuit, mga ganyan, heater control, and phase control. So in recent year, SCR had been designed to control power at high as 10 megawatts, okay, with individual rating as high as 2,000 ampere yata at 1,800 volts. So mataas ang control power ng silicon control, which is hindi kaya gawin ng PET natin saka ng BJT. Although yung BJT medyo na nagiging obsolete na siya, mas madalas na ina-apply ngayon is MOS and PET. Okay, kasi ang MOSFET saka yung PET o FET o kaya mga CMOS, which is mas fast switching, they are for digital, tawag dito. Madalas sila sa digital application. Okay? Yung BJT, okay pa naman din siya, pinakamura, pinaka-simplest to design, and okay pa naman din siya sa amplification, but we have a type of power MOSFET na din na we can also amplify high voltage. Okay? So, ganun na yung mga devices natin nowadays. Pero in a high power application with a greater precision, okay, na kailangan yung silicon control rectifier natin. Kailangan kasi mas maganda mas precise yung yung pacing ng semiconductor throughout the SCR. So yung SCR pala is a switching devices for high voltage and high current operation. Okay? Like ordinary rectifier, silicon control rectifiers conducts in one direction. It's simply to say that this silicon control rectifier can act like a diode, okay, or a switch. Okay, kasi one direction. Ibig sabihin, kapag nag-on yung switch natin or nag-close yung switch natin, may merong voltage na nagko-conduct. Kapag nag-close yung switch natin, ay kapag nag-open yung switch, ibig sabihin walang current na nagko-conduct on your semiconductor. Ganun yung sa SCR din. Okay? So we have yun nga itong okay. So, ano natin dyan, yung SCR also is a rectifier constructed from a silicon material with a third terminal for a purpose. Okay? So, silicon was chosen because alam naman natin yung pinaka-abundant yung silicon. At the same time, it has a high temperature and power capabilities. So, the basic operation of SCR is different from fundamental two-layer semiconductor. Okay? And yung natin, two-layer semiconductor natin, meron tayong anode, cathode. Dito meron tayong third terminal we called a gate. Okay? This determine when the rectifier switch from open and short. Open circuit ba siya or magsha-short circuit yung silicon control rectifier natin. Okay? And then malalaman natin mamaya bakit siya tinawag na rectifier. Okay? Which is binanggit ko kanina, pang chopper din siya eh. So, ibig sabihin, pang chop siya ng signal. So, makikita din natin yan. It is not enough to simply forward bias yung natin, yung anode-cathode region. Diba? Sa diode natin, kapag pinoward bias natin siya, may conduct na, meron magkakaroon ng diffusion, okay, between anode to cathode. In the conductor region, the dynamic resistance of silicon control rectifiers around di ko lang nilagay dito yung characteristic niya. Pero nasa libro naman yun. Okay? Yung characteristic, yung dynamic resistance niya. It's typically around 0.01 ohms to 0.1 ohms. So, dynamic resistance niya yan. This is a minimum resistance when the silicon control rectifier is conducting. Okay? So, yan yung dynamic resistance niya. So, yan yung typical niya. And then, kapag nag-reverse bias naman tong silicon control natin, okay? So, yung magiging reverse resistance niya is around 100 kilo ohms or more. Okay? Depende sa kanyang effect. Okay? Kapag naka-reverse siya. So, kailangan mataas ang resistance natin kapag reverse. Mababa kapag conducting. Okay? Yan yung makuha natin kapag mineasure natin. Okay? So meron tayong tatlong terminal nga, anode, cathode, gate, and this one is yung natin, yung wait lang, malit sa akin pero baka malakas sa inyo. Okay. Lakayan ko lang. Yan. Okay? So so meron tayong anode, okay, which is the positive side, cathode, then gate. So papansin niyo lang siya is a diode na nilagyan lang ng gate for the trigger. Okay? And then kapag tinignan natin yung yung layer by layer niya. So ito yung base construction ng silicon control rectifier natin, which is NP. Okay? So this is the basic construction niya. Have more parang din yan, pinagsamang dalawang BJT. Okay, itong silicon control rectifier. Okay, so parang ganito siya yung itsura niya. Okay, so meron tayo isang PNP na BJT. Yan. And another PNP na BJT. Yan. Parang ganyan yung magiging itsura niya eh. So ito yung Q2 nyo, tapos Q1. Tapos ito yung part ng anode. Okay, kasi PNP to, no? And then ito NPN naman to NPN. Okay, para N yung dulo eh, kasi N yung dulo dito. So, PNP, then NPN. So, ayan. Tapos dito yung cathode. Tapos ito yung gate. Okay. So, ito yung equivalent ng silicon control rectifier when we use a PNP BJT tsaka NPN na dahil so parang ganito yung itsura niyan kapag ni-layer by layer natin siya. Okay, itong tatlong layer na to. Okay, kung tatatlohin natin itong layer. Sabihin natin maliit na dopant yung kabila. So PNP. Then kumbaga ito connected to. Okay. Dito sa natin, sa NPN natin. Sabihin natin ganyan siya. Okay. Yan. Ito, di ba? NP. Yan. So, NP, ibig sabihin connected, then connected to. Tapos ito yung cathode. Tapos ito yung anode. Okay. Of course, nandito yung gate pang trigger. Ayan. So, parang ganyan yung niya. Yung itsura niya kapag pinor-layer natin itong So, ganyan yung connection dito. Okay. So, paano ba i-clear to? Yan. So, we have also here in yung mga different yung mga different type ng we have a hindi ko gano'n makita. Wait lang. Okay, so we have here the may parang may cup di tayo dito. Yan yung mga different type ng ng mga SCR tsaka natin. Okay, nasa baba. Then next. Okay, so we have the basic operation ng silicon control rectifier natin. Okay, so to switch an SCR, we need to, of course, forward bias yung natin. So, we denoted as BF. Okay. And apply the supply gate voltage, which is yung gate. And then the gate current natin. Yan yung natin, kailangan to switch on yung SCR. So, kailangan meron tayong forward voltage and yung apply sufficient gate voltage in controlling the silicon control rectifier. Okay, so these are the following hindi ko lang gaano makikita kasi zoom pa siya. Okay, so ayan yung niya, yung graph niya. Makikita natin dito, ito yung forward ito yung forward break. Hindi pala siya na Nakikita nyo ba yung sinusulat ko, class?
Hindi po, sir.
Hindi nga. Akala ko pati kanina nakikita nyo.
Sir, yung kulay red po na pen writing.
Saan yun?
Kita naman po yung kulay red na sinusulat niya, sir.
Yung itong pangalawa, nakikita ba?
Yung, scribble lang po.
Paano?
Yung pabilog-bilog na sinusulat niya po.
Oh, ba't dito sa ano kabila ako din nakikita? I mean sa phone ko. Yung iba nakikita
Sir,
nyo?
sa amin, sir. Sir, hindi man, sir.
Hindi po. Kaya pala. Paano niya to? Ako nga rin, dito sa phone ko, di ko naman siya nakikita. Ngayon ko lang kasi ginawa yung susulat sa ano eh. Dito sa ano, PowerPoint na presentation. Paano siya? Paano nyo enable yung sa inyo?
Nakita na po agad, sir.
Nakikita na agad? Yung iba wala din eh. Pati sa phone ko, ganun din eh. Ayan o. Wala o. Sa akin, dito sa phone ko, wala. Bakit kaya?
Baka sa phone po, sir, hindi pwede.
Sa phone, hindi pwede. Sa laptop lang, no?
Opo, pero hindi po ako sure.
Wait lang. Kaya pala, wait lang, ano natin. Hindi, sige, iwasan ko na lang magsulat-sulat sa ano. Okay. So, yan, makikita natin dito sa may drawing part. Ano kaya to? Sa phone, di pwede siya, no? Ayan. Wala, di nga nakikita. Sa laptop nga lang yung may nakikita. Okay? So, yan, so, in-operating na lang ng i-review nyo na lang yun sa PDF. Doon naman yun sa PDF eh. Silicon control rectifier must be switched on through forward bias, the anode, cathode, and the terminal, which is yung BF. So, ibig sabihin kapag yung may sapat kang voltage na in-apply sa gate to trigger, katulad din siya ng BJT. Sa BJT naman ang control naman natin doon is what's called that one? Base. Okay, depende kung anong common siya. Okay? Yung BJT natin. Ang silicon control, kapag yung sufficient yung in-apply natin voltage doon, magkakaroon siya ng conduction. You can see here, dito, meron tayong minimum voltage before magkaroon tayo ng typical conduction yung natin. So, ibig sabihin, malaki yung niya, itong parang curve. Okay. Itong parang curve dito. Okay. Ito, malaki yung wait lang nakakawa ako doon sa hindi nakikita. I-stop presenting ko muna, no? Kasi nakikita eh. Saan nakikita? Wait lang. I-save ko muna na PDF. Yan. See? Ayan. At least yan dito kita na. Okay, so ayan, kita na to, no? Okay. I think kita na naman to. Kita na to, class. Nakikita na yung parang sulat niya. Ayan. Meron
Yes, sir.
naman. Okay.
Yes, sir. Meron na po.
So, yung kanina pa lang pinagsusulat ko dito, di nyo nakikita. Okay. So, ayun nga, we need ng forward voltage. Kung papansin nyo dito, class, ayan, no? So, ito yung initial state where your gate, tawag dito, yung gate natin is naka-turn off siya. Okay? Naka-turn off. So, and then once na nagkaroon tayo ng okay, tinrigger natin siya. Nag-trigger tayo. Okay, magkakaroon dito ng na hindi agad magti-trigger agad yung natin. So, parang dating ipiprevent nung yung conduction barrier niya. So, to prevent it na totally magkaroon tayo ng conduction. Okay? So, yan. Tawag natin dyan breakover voltage eh. Okay, itong part na to, which is the break RB. Ito yung time na yung natin, voltage enter the conduction region. So, ito yung part na mag-enter na conduction, which is yung IG natin 0. So, wala ka pa rin IG dito at this time, in this part. Pero, nagkakaroon na ng conduction dun sa SCR natin. Okay? So, then pagdating dito naman, ito na yung tinatawag natin forward conduction na where freely na nagpo-flow yung current. Okay, totally. Okay, dito. Kumbaga, itong resistance natin sa SCR, virtually zero na siya. Okay, which is yun nga, nabot niya na yung dynamic resistance na 0.01 ohms to 0.1 ohms. Okay. So once the SCR is switched on, it remains latch, okay, on even when the gate signal is removed. So ibig sabihin, ang kagandahan nito, okay, ang kailangan lang natin to trigger SCR is kaparehas lang din ng conduction ng mga LEDs natin o kaya ng diode natin. Sa around 0.6 volts to 0.8 volts, okay? Ang niya, ang range. Pero kadalasan ginagamit natin 0.7 which is the average, okay? Pero in contrast, yung BD natin o yung voltage to minimum voltage to forward the SCR is 0.6 volts o kaya yung voltage sa gate natin must be around 0.6 volts. Let's say like that. Okay? So yan yung required natin to trigger on yung natin o ma-overcome niya tong BR natin or the forward breakover voltage. Okay? Then yun nga, kahit tanggalin natin yung yung source sa gate natin kasi usually ang SCR natin, okay? For example, meron ka ditong motor naka-connected. Okay? May motor pang connected dito. Okay, then meron tayong silicon control rectifier. Okay, so silicon control rectifier. So, sabihin na. Okay, so connected siya dyan. So, once na which is 0.6 volts yung supply natin. Okay. Once na switch on mo to, so yung gate natin magti-trigger and then magta-turn on na yung motor natin. Then kahit i-remove natin to, okay, i-remove natin to, still yung conduction, bigla mo ni-remove siya, tinanggal mo yung source o kaya yung ginawa. Kung switches to, okay, tinaas mo lang siya, in-open circuit mo siya, and then, of course, din na-connected yung source. So, still, yung gate natin will be, tawag dito, mag-turn on pa rin siya. Okay, para lang siyang, switch, malito. Okay, para siyang switch na na connected. Okay? Ayan. And then meron tayong holding current is the minimum required current to conduct the anode to cathode. Okay? Yan yung holding current natin. So, ibig sabihin, once na yung holding current natin, hindi na achieve, hindi mag-turn on yung SCR natin. Yan, yung holding current natin is the minimum, is the value current below which SCR switches from conduction state to forward region under this under this condition. Okay? Ayan. Papapansin niyo dito yung holding yung natin is minimum niya is IG 0 volt. So ibig sabihin kapag once na lumampas siya sa 0 yung IG natin, lumampas niya sa 1, ibig sabihin yun na yung minimum current na required niya para mag-turn on. So, okay? So somehow dito yun. And then reverse breakover voltage is the maximum reverse bias voltage sa SCR natin. Okay? So maximum maximum reverse breakdown voltage. Then next, to switch off naman, ito makita nyo yan, yung maximum break, So, sa region natin, so we have the minimum voltage. Okay? Na magkakaroon tayo ng breakover voltage. So, ibig sabihin, magiging negative na yung output natin So, dito, almost virtually 0 volts pa yung makukuha natin pag nagre-reverse tayo ng voltage. So, once, mangyayari lang yung reverse breakover voltage kapag yung biasing natin sa gate is reverse also. Okay? Kung yung natin, pag-trigger niya is positive, negative. Okay? Pare, ito yan. Tapos connected siya sa gate. Okay? Ito yung connected siya sa gate. So, pag ni-reverse mo siya, doon magiging negative yung yung input natin na voltage sa gate. Magre-reverse bias siya. Okay? So, remove the power source, okay, the anode cathode terminal, okay, then reverse bias the anode cathode terminal. So, yun yung way natin to switch off the SCR. So, okay, number 1 is to remove the power in the anode cathode terminal. Okay, paano natin gagawin yun? For example, ito yung tinitrigger natin. So, we need to remove the power here, yung connected sa anode cathode, para mawala yung mag-switch off yung SCR natin. Another way naman is to reverse yung biasing ng anode cathode natin. Okay, kung positive negative to, i-reverse natin na negative positive. So yun yung way para ma-switch off yung SCR. Okay? Iba yung class yung reverse Yung reverse class, i-reverse natin yung biasing ng gate natin. Pero ito, pag switch off naman ng SCR nga is to removing the main source natin and then reversing yung bias ng anode and cathode. So, yun yung way para ma-turn off yung SCR natin. An SCR cannot be switched off by simply removing the gate. Okay? So, mapapansin nyo kanina dito, kahit ni-remove na natin yung gate or still, yung natin, naka-latch. Ibig sabihin ng latch, ibig sabihin continuous lang yung operation kahit na ni-remove na natin yung pang switch. Di ba ang gate natin, ang ginamit natin yung gate pang switch on ng SCR. Okay? So, nag-switch on siya, nag-trigger siya, so nag-ooperate ng SCR. So, we cannot do it by normally way na mag-turn off siya by turning off yung power doon sa gate natin. Di mangyari kasi naka-latch na yung circuit, continuous na yung yung thermal aggregation sa silicon control rectifier natin naka-latch. Continuous lang yung operation para kapag parang ganito, parang relay siya. Yun nga lang, ang silicon control rectifier, nag-apply, pinag-trigger mo siya ng for example, gusto mo paganahin yung motor natin, which is mataas yung power requirement. To trigger a high power application, okay, at para hindi ka magsayang ng malaking power, maganda gamitin mo pang switch on is small signal lang. Okay, small signal voltage, okay? Or small signaling. Ganun yung gate natin. Small signal lang kailangan natin 0.6 volts to trigger a high power application. Okay? So dati kasi nung gumagamit pa tayo ng mga relays ganyan, malaki yung mechanical loss na nangyayari because hindi siya ganoon kabilis yung switching niya. O kaya dati yung mga pang switch dati is mga vacuum tubes, okay? Mga vacuum tubes yun. And those vacuum tube, high power na application mo, high power pa yung switch. So it's very impractical to use those things. So the best way is to have a control na kaya mag-control ng high power pero nag-apply ka lang dun sa mismong sa mismo control natin na small voltages, okay? So yun yung silicon control rectifier natin. Yan. So ito yung way natin to turn off yung silicon control, okay? We call this one is commutation circuitry. Can be used for satisfying either condition for the switch off on an SCR, okay? So tawag natin diyan commutation. If tinanong man yan sa madalas lumalabas sa board exam, commutation circuitry, okay? Either this one to removing the power of the anode control terminal or reversing the biasing condition of anode cathode, okay? So SCR commutation is simply a class of switching devices connected in parallel, okay? Okay, simply in parallel switching devices connected in parallel switch in SCR. A control signal activates the switch's circuitry and provides low impedance bypass for the anode to cathode current. So this moment, the totally loss of the current through the SCR to turn off. So the switching circuitry can also apply reversing the bias across the SCR, which also turn off the SCR natin. So mapapansin natin dito, okay, na yung way kung paano natin ito turn off yung SCR by removing the siyempre dapat pag turn off siya wala magpapass na current through the anode, okay? Pero naman monetary loss lang naman siya, okay? So sa lang siya, suddenly switching yan, activating. So this is one way to do it. Okay, next, posttriggering. An SCR can be forced to trigger conduction under several conditions must be avoided. Okay. Number 1, excessively high voltage from anode to cathode. Okay. High frequency signal from gate to cathode and high operating temperature. So those are the posttriggering ng silicon control rectifier natin. So pag sinabing posttriggering, it can be kahit wala kang ina-apply, okay, basta complete circuit mo nandun lang, it can be pulse trigger. Ibig sabihin bila nag-switch on to yun nga, excessively high voltage through anode cathode, di kinaya yung power, which is karaniwan lang 10 megawatts lang yung SAR natin. So at higher than that, okay, hindi niya kaya. High frequency signal from gate to cathode, okay. So especially yung SCR natin is operating only at low frequency signals. Okay? Kaya maganda siya sa mga low frequency pero yun nga, low frequency pero mataas yung high power application niya. For example, madali niyo makontrol yung yung 220 volts 60 Hz, okay? 100 sa America 110 volts to 60 Hz. So it can easily operate that. And high operating temperature. Although ang silicon control natin is operating at high temperature, which is around 67 degrees Celsius, typical, okay, not more than 80 gayata. It cannot operate in a in an environment with mas mataas yung temperature niya, like mga planta na na may okay, like geothermal ganyan, okay, which is kailangan mas mataas yung capability ng pag-control niya, especially in high temperature. Okay. SCR phase control. So the gate voltage can be set to fire the SCR at any point in the AC cycle. Okay. So for example, tinitrigger natin AC to, no? In this example, an SCR fires as soon as AC cycle crosses 0. Therefore, it acts like a half-wave rectifier. Okay. So example, ito yung natin. Okay. So, kadalasan ginagamit natin rectifier is diode. Okay? Either half-wave rectifier or full bridge rectifier. SCR can do that also. Okay? For example, ito yung signal natin na papasok dun sa SCR. Ito yung mismong SCR natin, no? Okay? And then, of course, naka-switch off siya. So, ibig sabihin, complete pa yung signal natin dyan. Okay? And then, itong part naman, ito yung mechanical electrical, to trigger lang din tong SCR natin. Once na nag-close yung switch natin, okay, nag-close yung switch, okay, tendency, magpo-forward bias siya. Since anode-cathode siya, class, so ang i-permit lang na signal ng SCR natin is yung positive cycle. Okay? So ayan. So mapapansin natin na pine-permit niya lang yung positive current. So ibig sabihin positive current lang yung papasok dito sa natin, dito sa conduction natin. Dito sa IL. Okay? Papansin mo kapag nag-loop tayo diyan, di ba? So parang switch, sabihin natin walang resistance to, no? Itong SCR, no? So ito yung IL natin. Ayan. Parang ito yung load natin, output. Okay, ito yung BL. So mapapansin nyo na kapag nag-apply tayo ng 4 voltage ay positive cycle, okay? Matitira na lang yung positive part niya. And then kapag nag-reverse bias to, okay, nag-reverse bias, negative mo, so ibig sabihin virtually zero yung makukuha natin dito sa RL. Okay, wala kang makukuha dito eh. Lahat kasi nandito lahat yung natin. Yung walang inallow na current pumasok dito sa SCR natin. So, virtually zero siya kapag negative cycle. Then, babalik ulit siya. Okay, so this is a half-wave rectifier. So, maganda talaga siya gamitin yung natin. In this example, the SCR fires later than 90 degrees, point of positive half cycle. So also, in pwede natin din i-control yung firing ng natin ng SCR. So, for example, ito, okay? So, meron tayong pag-control. So, pwede natin control yung conduction niya. Okay? So, sa conduction niya, hindi siya clear dito eh. Note nyo na lang. Yung firing angle kasi. Hindi nyo din-discuss. Ayan. So, meron tayong tinatawag na na firing angle. Okay? Ito yung firing angle. Ito yung dinidelay mo yung pagkaroon ng conduction ng SCR. Dito, class, sa kabila. Okay? Saan ba yun? Ito sa lecture natin dito. Okay? We can have kasi ang firing natin dito, pwedeng kasi ganito yung firing angle natin. Ito yung firing. Okay? Ito yung time na yung SCR natin. Okay, ito yung signal niya kapag dinidelay niya yung pagkakaroon ng conduction. Okay? So we can control yung na yon, yung pagkailan siya magkakaroon ng conduction dito. Okay? So nagkaroon ng conduction dito sa 90 degrees. Okay? So pwedeng ganyan yung itsura niyan. 90 degrees yung niyan. Which is nag-trigger lang yung SCR or nag-turn na yung SCR natin at the moment na reach niya yung 90 degrees half cycle ng natin ng signal. Okay? So doon lang yung tawag natin doon firing angle. Okay? Gaano kalaki yung firing angle before na magkaroon ng conduction doon sa SCR. Okay? So for example ito, we have yung sine wave natin, then meron kang firing pulses natin. Dito naka-pulse. So, ibig sabihin, itong pulses na to, dinidelay natin yung pag-turn on ng SCR. So, hindi siya mag-turn on. Okay, dinidelay natin. So, ngayon, na kapag itong dalawa na to, di ba kapag positive, pag sa SCR, nag-rectify siya, so positive cycle lang yung i-allow natin. Okay, so positive cycle lang dito. Okay? And dahil meron tayong firing firing angle na for example 20 degrees, 30 degrees, so ibabawas natin dun sa na-rectify na signal. So ito ibig sabihin itong output na to, ito yung tinatawag nating ito pa lang yung conduction niya, which is meron tayong 30 degrees delay before mag-conduct yung SCR natin. Tawag natin doon firing angle. Okay? So this part, so ito yung firing angle natin to. Okay, ito yung part na bago mag-turn on bago mag-conduct yung SCR natin. And then yung conduction angle naman natin. Okay, conduction angle ito. Okay, o kaya simply conduction lang yan. Okay? O conduction waveform. Kumbaga matitira na lang sa waveform. Kung 90 degrees yung firing angle natin, okay, so ibig sabihin mag-i-start yung conduction natin at 90 degrees phase. Okay. Yan. So, para magiganyan yung magiging tsura niya. Then, ito yung ibig sabihin, ibig sabihin sa gate pala, pwede natin makontrol yung laki ng firing angle. Although may mga computation to, pero hindi na natin in-include. Okay? So, some of computation, I will include na lang sa susunod nating meeting. Okay? May mga computations ka dito, pero simple lang naman yung computations niya. So, hindi na natin ganun ka expand. Okay? So, application. In this application, the SCR gate circuit is used to monitor situation and trigger the SCR to turn on a portion of the circuit. Okay? Example niyan, battery charging regulator. Okay? So, we use SCR. Okay? For example, sa charging regulator kasi, hindi pwedeng sumobra yung pag-charge natin dun sa natin. Protective circuitry pala yun. For example, positive portion lang kailangan natin. So, para lang sa pag-charge ng to regulate the battery. Ayun. Temperature control circuit. Okay. And then emergency lighting system. Okay. Ayan. So, I think dalawang semiconductor yung i-discuss natin for today. The next, silicon control switch. So, ito yung counterpart naman ng silicon control switch natin. It's like a SCR, except that it has two gates. Okay? So, mapapansin nyo meron kang dalawang gate. And these gate are individually trigger for the anode and cathode gate ng anode and cathode nyo. Either gate can be paired as SCS. So, kapag a positive pulse voltage on the cathode and the negative pulse voltage on the anode. So, yung SCR kasi natin can only conduct in a one cycle. For example, kung positive mo siya sinet to trigger, positive cycle siya mag-trigger lang. Okay? Pero ang silicon control switch natin is a bilateral semiconductor. Ibig sabihin, can either operate at positive and negative cycle. So, hindi kaya gawin kasi ng SCR nyo. Isang portion lang. Ito kaya nyo gawin. Dalawa, pwede siya mag-conduct. Okay? So, ito yung symbol ng natin, ng silicon control switch. And then, ito naman yung yung basic construction niya. Okay? So, either gate switch off. So, pwede rin pag switch off natin sa kanila, either gate can switch off through SCS. Kung pwede mo siyang i-pair ng magkaiba. Pero same operation ng SCR pa rin natin. Okay, i-remove mo yung continue pa rin siya magko-conduct. So, kailangan mong mag-commentation o kaya i-reverse yung polarity ng anode and cathode mo para ma-turn off siya. O kaya remove mo yung power na nagsusupply dun sa anode gate natin. Okay? So, a negative pulse of voltage on the cathode gate, a positive pulse of voltage on the anode gate. Okay? So, yan, negative pulse na i-apply mo sa or voltage on the gate. So, yan, depende sa type of natin. So, SCR in comparison, SCS has a much much lower power capabilities compared to SCR. So SCS has faster switching time than the silicon control rectifier. The silicon control switch can be switched off by the gate control. So hindi katulad ng SCR, hindi kayang tawag dito. I-turn off by gate. Okay? Pero sa SCS pwede siya. Okay? So we can do that by putting switching off negative pulses or voltage sa cathode gate natin. Okay? Ayan. Ayan. Okay. Kaya positive pulse naman sa anode gate natin. Okay. Kapag nagta-turn on kasi tayo, diba positive pulse sa cathode, okay. Negative pulse naman sa anode. Okay. King application, kadalasan ginagamit siya sa pulse generator, voltage sensor, saka alarm circuitry. Okay. Next, GTO, gate turn off switch. So gate turn off switch are similar in silicon control rectifier, except that the gate can turn the GTO on and off. Okay. Ibig sabihin, pwede mo siyang gawin na maglagay ka lang ng pang switch off, switch on through its gate. It's conduct only in one direction. Okay. So this is a mas improved version of the silicon control rectifier. Although yung conduction niya in one direction, pero pwede mo na siya turn off sa gate. So ito yung typical na halos kaparehas lang class ng ng SCR natin. Okay? Yan. Application niya, counters, pulse generator, oscillator, and then voltage regulator. Although yung SCR natin voltage regulator. So GTO comparison to the SCS. GTO is a slow power devices. So mas lower yung power application niya. So kaya pa rin, kung high power application ng kailangan mo, SCR pa rin ang gagamitin natin. Kasi ganun din si silicon control switch. Kasi kapag pinabilisan natin lalo yung switching natin. Okay. Tsaka pinababa yung doping. Mas bababa yung capability niya in high power application or high power. So low power device siya. This gate necessary to power the GTO is larger than the SCR gate signal. Okay, so we need a larger voltage to power the GTO. The gate signal necessary to turn the GTO off is similar to the SCS. Okay, kasi pwede siyang i-switch off sa gate. The switching rate for turning the GTO off is much faster than the SCR. Okay, so mas mabilis siya sa pag-turn off. Then, LASCR, a light activated silicon control rectifier. Okay, so pag sinabing light, sabihin we can trigger, it can be used by means of light. Okay, so yan, pag may ganitong symbol ka o kaya ganyan na wavelength, ibig sabihin that semiconductor uses light to trigger. Okay, light beam. So SCR is a SCR that can be powered a light beam striking the gate cathode junction or applying the gate voltage. Okay. So meron tayong particular wavelength. Kailan yung possible na pag-trigger niya. So papansin natin around siya yung effective radiation niya around 20 megawatts per centimeter squared. Okay. So para ma-trigger yung SCR. Tapos ito yung minimum. Ito yung niya gaano kalaki yung yung kailangan nating radiant energy or radiant core para magkaroon ng conduction sa LACR natin. So application nito, optical light controls, relays, phase control, motor control, and then computer application. Okay. So ito yung symbol niya. Next, Shockley diode. So Shockley diode conducts once the breakover voltage reach, it only conducts in one direction. Okay. Kaparehas lang din ng ng typical conduction niya sa SCR, around 0.6 volts to 0.7 volts. Okay. Ito yung anode cathode niya, then ito yung symbol niya. Kaya ito lang yung portion niya, can only conduct in in that direction lang din. The Shockley diode must be forward biased. Then once the voltage reach the breakover level, it will conduct. Unlike SCR, only conduct in one direction. Application trigger switch for ESCR. Okay? So madalas nilalagay yung Shockley diode class sa kasama ng gate. Okay? Bago mag. So ayan, ito yung ano niya. So walang capability na yung Shockley diode natin mag-reverse bias siya. Okay? So typically ang reverse bias niya pag ganoon siya. So hindi magandang gamitin yung Shockley diode natin, reverse bias application. Okay? Ito yung lumang version ng diode, okay? Yung Shockley diode. Then we have diac, okay? Actually itong mga to summary lang to eh. Itatry natin elaborate pa tong itong mga devices na to each, okay? Wala pa kasi yung nila yung may mga competition. Then diac is a breakover type device. Okay? So, tingnan niyo dito, dalawang nakaparallel na diode. Okay? Meron tayong anode 1 and anode 2. Once the breakover is reached, the diode conducts, though can be conduct in both direction. Okay? So, breakover type, ibig sabihin ng breakover type, ito yung type ng ng devices na it's required to have a minimum voltage para magkaroon ng conduction. Okay? So, it reach the diode conducts. The diode though can be conduct in both direction niya. The breakover voltage approximately symmetrical for the positive and negative breakover voltage. So, ayan. Mapapansin natin dito sa yung breakover natin. So, ito yung di ba? Minimum voltage to conduct yung natin. Yung ECEP. Parehas lang naman ng yung diode natin. Okay? So, symmetrical siya. So, ibig sabihin yung diode natin can operate at positive portion of the cycle and then the negative portion of the cycle. Okay? So, they are triggered circuit for the triac and the proximity sensor circuitry. Okay? So, ginagamit yung diode natin. And lastly, hindi pa pala to. Diode. Okay? So, diode natin na yun. Meron ko tayong pangatlong layer. So, kumbaga, ito, diode, anode, cathode, wave. Pag nilagay mo ng triac siya, okay? A triac is like act like diac, pero meron siyang control terminal, which is the gate. When firing the gate by exceeding the breakable voltage, a triac conduct in both direction. Okay? So ayan, ang kagandahan lang naman nito, meron kang pag-control dun sa phase angle niya, which is yung gate. Okay? So they are used in power control circuit. AC power control circuit. Okay. So dito kasi wala tayong control dun sa conduction ng diac natin. Wala tayong control, okay? Pero dito sa conduction ng triac, may control tayo kung kailan magkakaroon ng conduction yung output natin o yung sa load natin. Okay, so these are the triac terminal application, okay? Yung mga Then UJT, unit junction transistor. So mapapansin nyo, halos sunod is more on tawag dito. Unit junction sila eh. Yung diac, triac, those are unit junction. The unit junction transistor has two base terminal. Meron tayong B1, B2, para siyang base 1, base 2, and then the terminal. Okay, so ito yung typical na circuit symbol niya. UJT symbol resemble katulad siya ng PET. Okay? Pero ang terminal lang natin doon, kung doon sa PET natin kasi source, drain, tsaka gate. Dito sa UJT natin, ang terminal natin is emitter. Okay? Emitter yung control natin dito. Ayan o, control. So yung base and B1, kung saan magkakaroon yung na conduction natin. Okay, so UJT equivalent circuit, the internal base resistance we call the RBB, Ayan, ito yung RBB natin, internal base resistance, is the total resistance between the two base natin, which is terminal when IE is equal to 0. Okay, so ito yung RB2, RB1, so naka-potentiometer siya para dito yung control natin. Okay, yan yung control natin. So, depende kung ano yung internal base resistance nito, gano'ng kalaki. Pag pinagsama natin si RB2 tsaka si RB1. And then, may characteristic yung UJT kung kailan gano'ng kalaki yung ratio ng internal base resistance natin. Yung tinatawag natin yung intrinsic standoff ratio. So, static standoff ratio is the ratio between RB1 to RBB when IE is equal to 0. Okay? So, usually class, ito, nasa specification na to ng UJT natin. Makikita mo yan. Okay? If for example, may magano tayo, UJT spec. Sample lang ng devices. Okay. Yan. Dito, usually kapag ito, hanapin natin to, nasa mismo ano na yan. UJT na yan. Okay? So, yun. Hanapin mo lang tong ratio. Although, may mahaba lang kasing computation nyo kapag kinompute natin eh. Okay? So, conduction through emitter terminal, we can know, okay, the reduction, okay, which is BP is equal to, standoff ratio, BBB, which is the voltage between the, the internal base resistance. Ayan. And then yung forward voltage natin, okay? Which is usually yung forward voltage nga natin is 0.6 volts. Okay? Yan, kadalasan ng natin, forward voltage natin 0.6 volts. So ito yung peak performance voltage. Okay, peak voltage niya. We can easily solve it. UJT resistance region. After a UJT parse, the emitter voltage decrease as emitter current increase. Okay. So, ayan. So, we have here and kapag umabot yung natin, emitter natin into saturation region. Okay. Kasi itong part na ito yung cutoff region eh. So, magkakaroon na tayo ng negative resistance. Okay. So, abot siya sa peak voltage niya. Then yung BBB natin will be 10 volts. So hindi bakit tumataas yung voltage sa BBB? Kasi ito yung internal resistance mo. So the more na malaki yung BBB natin, the more na walang nasa reverse bias siya condition yung UJT natin. Okay? Ang output kasi natin will be determined in the dito sa part ng RB2. Okay? Dito sa part na to eh. Yan, and then magbabalik point siya, babalik siya sa saturation region. Okay? Which is yung BBB natin will be lower, and then yung natin dito babalik siya sa ulit sa BA at saturation. Okay? So the negative resistance region operating the device by the peak point, which is BP, and the valley point, which is yung BB. So tawag natin dito valley voltage eh. Okay? Yung minimum voltage where yung natin SCR UJT is reverse. Okay. Then UJT emitter curves. So emitter curves show the effect of BBB on firing the voltage in BP. Okay. So alam natin kapag yung BP natin, yung BB natin pinapataas, okay. So tumataas yung natin voltage sa BBE, and then halos magkakasim lang din naman yung yung current natin sa emitter. So the higher the value of BBB, the higher the value of PP required to pair the component. Okay. Okay, so we can also, so combination yung SCR saka UJT. Okay. So yung UJT natin, yan yung magko-control para magkaroon ng stability do sa gate. So UJT is commonly used in trigger device for the other breakover device like SCR. In this we have a ito kasi UJT, ito yung form of a oscillator na UJT. Okay, so yan, mas stabilize siya, so mas isa type of oscillator na magsusupply dun sa gate. Okay, the SCR show in this trigger when UJT emitter circuit conducts as the capacitor charge. Okay, when yung voltage natin sa B increase, kasi kailangan ma-charge tong capacitor pag gumanyan muna to, di ba, magsusupply, so mag-charge muna yung capacitor, doon pa lang magkakaroon ng contact, magkakaroon ng ng current across IE natin. Okay, so when it reaches in a conduction level, okay, when it reaches BP, the UJT pairs, the voltage develop across the R2, kung ano man yung voltage drop across the R2 will be the input of your gate. Okay? Yan. Ginagawa natin to para yung circuitry natin mas stable. Okay? Mas stable yung pag-trigger niya. Hindi kasi pwedeng source agad yung i-apply natin. So kailangan mas stable yung ina-apply natin voltage. So when we use UJT to trigger SCR, okay, so ganito yung magiging waveform niya. Okay, so meron tayong transit time because we use band trigger is yung capacitor. Kaya meron tayong tau R1 SC, which is the time response. Okay, time response yan. So yung time response natin nakadepende yan sa R1, okay, or yung R1 natin, the resistance between the RB1 plus yung R2 natin. And then yung sa BR2, ito yung pumapasok sa BR2 natin Okay, ito yung BR2, di ba? So ito yung pumapasok sa kanya. Ito yung output ng ito yung output ng UJT natin Okay. Output ni UJT yan dito. Ito kasing itong part na to, ito yung part kung saan nagkaroon ng trigger yung SCR natin. Next, phototransistor. Sa phototransistor naman natin is a light control transistor. Okay? So, yan, light control transistor. So, ibig sabihin, ganun din, meron din yung component na na may light beam ipapasok. Okay? Usually, may connection, yung mga phototransistor yan, BJT yan, na may kasama yan na photodiode. Okay, photodiode para kapag may pumasok na current, doon magpo-forward bias yung photodiode natin. Okay, so phototransistor is a light control transistor. The current through the collector and emitter circuit is controlled by the light input at the base. So the control current is the product of the resistor gain, which is HFE, okay, and the light induced base current, which is I lambda. Okay. So, yung I lambda natin, ito yung na-induce na current across your base. And then, yung transistor current, is a constant. Makikita natin yan sa specification. Okay. So, IC is equal to HFP lambda. So, ito yung ito yung current na mag-across dun sa from collector papuntang emitter niya. Okay. So, phototransistor package, usually gumagamit din ng isolate 1. Okay, which is DIP. So ito yung numbering niya. Tapos ito 6 pins lang to. Ito 16 pins. Okay. So yan. So para lang din naman siyang kung ibig sabihin meron kang 4 na component, ito isang component lang to. Kasi ito, isa lang yung common ito. Common ground lang. Then, opto-insulator. Sa opto-insulator naman natin, okay, kung ito phototransistor, so meron tayong photodiode. Okay, so photodiode, kapag parehas lang din siya ng natin, normal na diode, yun nga lang, light din na ginagamit. Okay, ito yung tsura ng mga photodiode eh. Yan, so yung mansura ng photodiode. Okay. And then, we have a Darlington. Okay. The Darlington photo. Basta, pag kinonect natin dito, yan. Ito, ganun naman to, photodiode na transistor naman ang kinonect natin. Okay. Ito, photo SCR, ganyan. So, we call them photo opto-insulator. Okay? Especially yung photo SCR natin. So, combination lang yung mga yan. Okay? Kumbaga, kung ano yung characteristic na SCR natin, lagyan mo lang ng photodiode dun sa circuitry niya, it will become an opto-insulator, which is, ang input natin will be light. Okay? Kaparehas lang din naman ang characteristic ng photo transistor natin. Okay? 10 PUT, which we call them a programmable UJT. Okay. In some of operating characteristic, PUT is more act like an SCR. Like UJT, PUT has a negative resistance region, but this region is unstable in the PUT. Ayan, mapapansin natin, it will be stable. So, pinakita lang dito yung forward biasing. Ito yun. It's siya. Okay. So, mapapansin nyo, kailangan mo ng malaking power para ma-turn on siya. Okay? In this state, still, your PUT still turn off okay, kasi unstable region, negative, and then, babalik ulit siya dito para magkaroon ng on state. Tawag nga natin dito value voltage pa rin. Kung kailan magkakaroon ng after triggering siya, okay, dito pa lang yung portion na magkakaroon tayo ng forward. I-elaborate pa naman natin kasi may mga may mga competition to mga to. But this region is unstable in PUT. The PUT is operated between the on and off state. Okay? So ito yung off state niya. Then ito yung unstable ng region. Still in this our PUT will be turned off pa rin. Okay, so malaking pinagkaiba niya sa SCR, no? Parehas lang yung symbol pero yung SCR dito yung gate niya connected sa cathode. Pero yung programmable yung UJT connected siya sa anode. Okay. So PUT, reducing or removing the gate voltage dies not turn off the PUT. Okay. Instead, like an SCR, the anode cathode must be dropped sufficiently to reduce the current below a holding level. So the gate voltage required to turn the PUT on is determined by external component and not specify of device as a value of UJT. So meron tayong BG, ito yung equation natin is equal to RB1 over RB1 plus RB2 BBB is equal to standoff ratio BB/RB. So ito yung sinasabi kong formula niya yung standoff ratio natin. So we can compute yung standoff ratio katulad din yung sa UJT kanina na RB1 over RB1 plus RB2. So ito lang naman, ratio lang din naman niya mga yan. Ang maiksi lang equation, hindi katulad doon sa UJT natin kanina, BP is equal to standoff ratio BBB plus BD. Pero dito lang, okay? Para makuha natin yung yung trigger natin sa gate. Okay, standoff ratio times BBB lang siya. So, yan. Okay. So, medyo hindi ko meron tayong mga part na hindi na-discuss, yung mga computations na. Bukas yung version to eh. Okay. Wait lang. Okay. So I think yan muna tayo for today. So next meeting ko na lang ano yung mga discussion natin para ma-discuss natin lahat yung problem solving naman sa mga natin. May mga formulas kasi akong di-discuss eh. Ito kasi more on lang siya, more on terms ganyan. Pero we can advanced reading na kasi in-upload ko na dito class yung yung PDF natin. 7 edition pala to. Okay. Yung di-discuss ko 10 edition. So medyo iba pala yung PowerPoint. So yun lang.